Alright, hey there guys. My name's Wilfrid and I'm a senior math tutor. Today I'll be covering 11 questions surrounding algebra and mathematics. A little bit of backstory upon myself. I graduated from master with a major in biochemistry and a minor in mathematics. And yeah, if you have any other issues with your mathematics homework or with your tests or quizzes or assignments, just submit them on OneClass through the portal and we'll get to them as soon as possible. Thank you so much for listening and let's begin. Okay, so the first question reads, graph the linear equation 3x plus 2y equals 12. So when it asks us to graph a linear equation, it asks us to basically interpret this line equation that we're given and put it onto a Cartesian plane. So we're going to first set up our Cartesian plane, and as usual, we're going to label the axes here, okay? So this is the x-axis and the y-axis. So usually people write the line equation as follows. So people usually write the line equation as y equals mx plus b, where m is the slope of the line and b is the y-intercept of the line. In this case, they gave us a different form of the equation, but we can still utilize this form to find our graph. And how we're going to do this is that we're going to try to find 2 points of the line. If we're able to find 2 points of the line, then we are able to graph the line entirely. So the 2 points that we're going to find are the x-intercept and the y-intercept of the line. Okay, and these are the easiest points to find because the x-intercept is where the line intercepts the x-axis. And that point is when y is equal to 0. On the other hand, the y-intercept is when the x is equal to 0, and it shows us where the line intercepts the y-axis. So all we really have to do is to set x to be equal to 0 and solve our equation, and set y to equal to 0 and solve our equation for the x-intercept and the y-intercept. Okay, so that's what we're going to do. And I guess the alternative method that you guys can use is by rearranging this equation to the standard form and finding the slope and the y-intercept. Okay, so we're going to do what the junior tutor does. Okay, so first we're going to calculate the x-intercept. I'm just going to write it short as x-int. Okay, so we're going to set y to be equal to 0. And if y is equal to 0, we get this. 3x plus 2 times 0 equals 12, okay? And we got 3x equals 12 and x equals 4. Therefore, x-int is 4 and 0. Okay, cool. So let's set the let's find the y-intercept, okay? So we're going to set x to be equal to 0. If you set x to be equal to 0, we get 3 times 0 plus 2y equals 12. Okay, and that equals 2y equals 12. And divide both sides by 2, and we get 6. So therefore, y-int is 0 and 6. Okay, so if we were to look at our Cartesian plane here, we're going to just label the units on here too. So we're going to have 1, 2, 3, 4. We're going to have 1, and all the way up here, maybe up here we'll have 6. Okay, so our y-intercept is 0 and 6. So we're going to put this. We're going to put a point here to signify that one of the points on our line is 0 and 6. And the other point is 4 and 0, which is here. Okay, so if we were to draw a line from here to here, we would get our graph. So I'm going to try to draw a line as carefully as I can. Okay, also you want to draw the line past these points because a line continues on the x-axis continuously. Okay, that's our line. I'm sorry about the squiggliness of it, but that's how you graph the linear equation from the 2 points of the line, which are the x-intercept and the y-intercept. Alternatively, you guys can rearrange this line equation. So we have 3x plus 2y. So we're going to set it into the standard form that we have here. So we're going to move our x to the right-hand side and isolate for y. So if we do that, we get 2y minus 3x plus 12. And we want to isolate for y, so we have to divide both sides by 2, and we get negative 3 over 2 x plus 6. So this is our y-intercept, which corresponds to our graph here. And this is a negative slope of 3 over 2, or 1.5. And this is consistent with our graph here because we notice that our line equation, or our graph, is negatively sloped as it's angled towards the negative side. So that's how you graph the linear equation. Given these two different methods, they both produce the same graph in the end. Okay, so this solution is correct. Good work. Okay, cool. Let's move on to question number 2. All right, so the question number 2 reads, if the domain of f of x equals 3x plus 5 of 3x plus 5 is negative 1, 0, 1, 2, and 3, what is the range? Okay, so like I explained in previous lessons, the domain is the values of x that defined our function f of x. Okay, so basically that means that any valid value of x that leads to another value or maps to another value. Okay, so I'm going to label that in red, and this is what we call the domain. Okay, so the range is all possible values of f of x from our domain. Okay, so, and this is all connected by our function f. Okay, so they gave us our domain, right, which is the set of negative 1, 0, 1, 2, and 3. And they're asking us to find f of x, right? So asking us to find, oh, what do these values correlate to, map to in our range, okay? So to find our range, we have to plug in each of these values into our function and see what its output is. And by doing so, we will be able to find the range, okay? Okay, so we're going to first do our function here. We're going to state our function here, which is f of x equals 3x plus 5. Okay, so let's first calculate f of negative 1. Right, so that would be negative 3 plus 5, and that would equal to 2. Okay, alright, so f of 0, that would equal 3 times 0 plus 5, and that equals to 5. F of 1, right? F of 1 equals 3 times 1 plus 5, and that equals to 8. And f of 2 equals 3 times 2 plus 5, that equals to 11. And finally, f of 3 equals 3 times 3 plus 5 equals 14. Okay, cool. So now we have found our range, and I'm just going to input it into our bubble here, which is 2, 5, 8, 11, and 14. Okay, so this would make sense for our range because in our domain we're given 5 values, so our output should be also 5 values of themselves. So that helps us to confirm that this is indeed our range with this restricted set up for our domain. Other than that, that's how you solve the problem. And so our range is, let me just write a statement here. The range of f of x is 2, 5, 8, 11, and 14. Okay, cool. So this solution. Cool. All right, let's move on to the next question. Question number 3. All right, so the question reads, if y varies inversely as to x, and y equals 8 when x equals 4, find y when x equals 16. Okay, so the phrase y varies inversely relates to our concept of proportions. Okay, so the proportional notation is this, and whenever we have this notation here, we say that y is somehow related to x. In this case, we say that y varies proportionally to x. That means when x grows greater, or x increases, y also increases. So when it means y varies inversely to x, that means that y is proportional to 1 over x. So when x grows bigger or increases, y grows smaller. And when y grows smaller, x grows. When y grows bigger, x grows smaller. Okay, so that's what it means when it says y varies inversely. Okay, so in the question itself, it stated that so we know that there's a proportional relation between y and x, and there's an inverse proportion. Okay, so given that, and given an example of this, find the relation between y and x. Okay, so from here we have to understand that the proportion between the inverse proportion between y and x is not necessarily 1-to-1, right? So we have to consider the fact that there might be a constant that also varies between these two. So, right, so from here we can write that y equals constant k times 1 over x. So we're maintaining the inverse proportion, but we're also considering the fact that there might be a constant that scales this relation, right? And from here, we can use the information that we're given by the question itself to find the constant, and through that, we'll be able to find out y when x equals 16, okay? So from here, we sub x equals 4 and y equal 8 into our thing, and this is what we get. So a equals k times 1 over 4. Okay, so now we're going to isolate for k. So we're just going to move our 4 over. So we just multiply both sides by 4, and we get 4 times 8 equals k k over 4 times 4, and we get k equals 32. So now we have found our constant k, and we can plug it into our relation. So therefore, y equals 32 over x. And now we can solve for y when x equals 16. So when x equals 16, so sub x equals 16, y equals 32 divided by 16, which is 2. Therefore, y equals 2 when x equals 16, according to y equals 32 over x. Right? So that's how you would be able to solve this kind of question. So we covered the fact that what an inverse proportion is, or an inverse relation is, which means when x increases, y decreases. And a really good example, if you want to graph this, is your reciprocal function here, right? So if I were to graph this inverse proportion relation, all I can say is, if this is the x and y axis, this is what an inverse proportion looks like, right? And also we have a negative side here, but we won't cover that for now. We see here as x increases, y decreases, and when x decreases, y increases. So this is what we call an inverse proportion, and that's what this is entirely. And by doing so, we also have to consider the fact that there might be a constant that relates between y and x. So we have to solve for this constant before we even try to solve for our actual question here. So we found our constant, which is 32. We actually found our relationship, which is y equals 32 over x, and we subbed in x equals 16 to find what y equals to, and y equals to 2. So this solution is correct. Cool. All right, let's move on to question number 4. Alright, so what is the nth term and the fourth term of the geometric sequence given that its first term is 5 over 2 and its common ratio is negative 1 over 2? So I need to cover what a sequence is first. So a sequence is basically a sequence of numbers that follows a pattern. So for example, a really simple sequence would probably be this sequence here, which is 1, 2, 3, 4, 5. So this is a arithmetic sequence, where each term in our sequence is plus 1. So you see here that our first term is 1, our second term is 2, so plus 1, plus 1, plus 1. So you see here the pattern is plus 1, plus 1. I don't need to explain it any further. Okay, so a geometric sequence, all right, follows a pattern where the next term in the sequence is multiplied by what we call a common ratio. So a very simple one will probably be 2, 4, 8, 16, 32. Well, the common ratio here is 2. So we multiply by 2, we multiply by 2, and each term in the sequence, the next term in the sequence is the multiplication of the common ratio by the last term in the sequence, okay? All right, cool. So let me rewrite the sequence out again. And so on and so forth, okay? All right, so we can rewrite 4 as 2 times 2, right? We can also rewrite 8 as 4 times 2, or we can rewrite this as 2 times 2 times 2. So do you see a pattern here? If I keep going, this can be written as 8 times 2, but this can be written as 4 times 2 times 2, but this can be written as 2 times 2 times 2, right? So if I were to write the general formula for each term in the sequence, it would be this, okay? So we would have our term that we're looking for, which is an, and it would be the first term of our sequence times the common ratio to the power of n minus 1. So we see here that 2 is also equal to 2 times 2, 1 minus 1, which is just 0, so it's 2. 4, okay, let me rewrite it here. So 2 equals 2 times 2, which is a common ratio, 1 minus 1, which is equal to 0, so that equals 2. 4 is equal to 2 times 2 to the power of 2 minus 1. 8 is 2 times 2 to the power of 3 minus 1, and so on and so forth, right? So this is the general formula for our geometric sequence, right? Which is, if you're looking for the nth term of our geometric sequence, it's just going to be the first term times a common ratio to the power of n minus 1. All right? So in this question specifically, they're asking us to find the nth term and the fourth term of a geometric sequence with the first term of 5 over 2 and the common ratio of negative 1 over 2. Okay, so if we, whoops. Okay, so if we were to calculate this, so we know that A1 is equal to 5 over 2, and we know our common ratio is negative 1/2. Okay, so given our general formula here, all we have to do is plug it in. So an equals 5 over 2 times negative 1 over 2 to the power of n minus 1. Okay, so this is our nth term. All right, so the fourth term will just be a of 4 equals 5 over 2 times negative half 4 minus to the power of 4 minus 1, or the power of 3. Okay, so that'll be 5 over 2 times negative 1 over 8. Okay, and that gives us negative 5 over 16. All right, cool. So that's how you would be able to calculate the nth term and the fourth term of a geometric sequence. So first of all, we stated what a geometric sequence is, which is a sequence of numbers that follows a pattern of multiplying by a common ratio. In this case, our common ratio here was negative half. And then by doing so, we were able to use the pattern of a geometric sequence to find its general formula here. And through the general formula, we're able to find the nth term and the fourth term. So this solution is correct. Good job. Cool. All right. Let's talk about question number 5. Give me a minute. I'm just going to open my window. Okay. Alright, I'm back. Sorry about that. So the next question reads, what are the factors of 3x squared minus 10x plus 8? Okay, so I've covered this a numerous amount of times, but I'll do it again. So to calculate the factors of 3x squared minus 10x plus 8, we're going to use a method I like to call cross multiplication. So basically, if I were to write out the general formula here, so it's ax squared plus bx plus c. Okay, so we want to convert this form into this form here, where dx plus e times fx plus g. Okay, so we want to convert our standard quadratic function into this factored form. And by doing so, we're able to find the factors much easier. Okay, so the trick with this is that our coefficients of d, e, f, and g relate to a, b, and c somehow. Okay, so this is the correlation between them. So a, coefficient a, equals d times f. So d and f are factors of a, actually. For c, the factors are e and g. And for a middle term, the factors are actually, so b is equal to d times g plus e times f. Okay, so we're going to find d, e, f, g where these three equations are true. Okay, so we're going to find factors of a and factors of c such that when factors d times g is summed with e times f, it makes coefficient b. Okay, and this sounds really complicated, but when it comes down to it, it becomes really simple. Okay, so we're going to do our actual question here now. So we have 3x squared minus 10x plus 8. So first of all, we need to think of the factors of coefficient a, right, which is 3. So what are the factors of 3? Well, we have 1 and 3. And since it's a prime number, we only have 1 and 3 and negative 1, negative 3. Okay, so what's the factors of 8? Well, we have a few to choose from. We have 1 and 8, negative 1, negative 8. We have to be aware of the sign too. So 2 and 4. And negative 4, negative 2. Okay, and you can switch the orders of these too. And these are, so just be wary about that. And also, these aren't coordinates. These are just the factors. I just put them in brackets. Okay. All right. So we need to choose a pair of factors from here and a pair of factors from here, such that b will equal the sum of this formula here. Okay. So this is basically kind of trial and error at this point. So let's pick the factors of, let's say, 1 and 3. Okay, let's put it in this way. All right, and for 8, we're going to pick the factors of, why don't we pick the factors of negative 2 and negative 4, like this. Okay, so we arranged our factors as so. All right, and this is why I like to call it the cross multiplication method, because now we're going to multiply these two diagonal numbers and these two diagonal numbers and add them together. And hopefully what we get is negative 10. Okay, So if we were to multiply 1 and negative 4, we get negative 4 plus 3 times negative 2, and that gives us negative 4 minus 6, and that gives us negative 10. So nice. We have now found our factors, because this this ordering of the factors gave us the middle coefficient b, right? So one thing to note is that, okay, so I'm going to rewrite our factors in a different way. Okay, so what if I said, oh, let's put the ordering of the factors like this and leave it like this, right? If I were to cross multiply this wouldn't equal negative 10 anymore, right? It will be equal to negative 12 minus 2, which is equal to negative 14. So the order, or the sequence of how you order the factors, really matters here, okay? Because what happens after we figure out that these are our factors is that this here becomes our first factor and this here becomes our second factor. So it's going to be 1, or x minus 2, and 3x minus 4 as our factors, okay? In this sense here, if we were to convert it, we'll get 3x minus 2 times x minus 4, right? Which is not the correct factors of our quadratic equation here. Right, so these are the factors, x minus 2 and 3x minus 4. These are the factors of our quadratic function, and we were able to do that by using this cross multiplication method. Right? Okay, so the junior tutor also got the correct answer. They used a different method. They multiplied the a and c coefficients together to find a product of 24, and they considered all the factors of 24, and then they identified the factors that was correct for them. And then by doing so, they were able to plug it into these parentheses and simplify for themselves. But I prefer my method better because it's a lot more simplistic. And after a lot of practice, you get used to it and you can just do it like mentally. So the solution is correct. Okay, let's move on to question number 6. All right, so we just talked about factoring, right? And so this next question is going to use that technique too. So the question reads, how do you solve 3x squared minus 2x minus 5 equal to 0? Okay, so now this question is asking us to find the values of x, which will make this equation true. So what values of x will make this left-hand side equal to 0? And we're going to do that by finding the factors of it, okay? All right, so we're going to first write out our equation, 3x squared minus 2x minus 5. And we're going to factor this, okay? So we need to think of the factors of 3, which is 1 and 3, right? So I'm just going to write that in here. So 1 and 3. And the factors of 5, it's also a prime number, so we only have 1 and 5. So I'm going to write it like this, negative 5 and 1. So since it's a negative number, we have to make sure that at least one of the factors are negative, right? So if we were to cross multiply this now, we would get negative 5 plus 3, which equals to negative 2. So we now have found our factors, which is 1x plus 1 and 3x minus 5. So this equals to x plus 1 and 3x minus 5. And now from this state, so this factored form is the same as this. But in this interpretable form, we're able to find the values of x, which will make this equation equal to 0. Okay. So the values of x will be whatever makes this bracket to be equal to 0 and whatever makes this bracket to be equal to 0. So all we have to do is actually solve for x plus 1 equals 0 and 3x minus 5 equal to 0. Okay, in this first one, we get x equals negative 1. So when x equals negative 1, this equals to 0. And if this equals to 0, anything multiplied by 0 is 0. All right, the second one is going to be 3x equals 5 and x equals 5 over 3. So when x equals 5 over 3, this equals to 0, and anything times 0 is equals to 0. So 3x squared minus 2x minus 5 equals 0 when x equals -1 or 5 over 3. Okay, so this is just one way of solving this problem. And the other ways of solving this problem, you can use a quadratic formula to solve it if you're unable to factor it, or you can even graph and find the x-intercepts of your graph. Because an alternative way of looking at this question is basically they're asking for the values of x that will, called zeros, that will equal this equation to 0. Another way of seeing it is that they're looking for the x-intercepts of our quadratic function, because the x-intercepts sets our y to be equal to 0, right? So those are other ways you can interpret this question, but this is the simplest way of doing it. All right, so they went through factoring, but we already explained how to factor, so we don't really need to cover this too much. But at this point, when they factored it, they realized that, oh, when we set these brackets to equal 0, the whole equation will be equal to 0. So we just solve 3x minus 5 equals 0 and x plus 1 equals 0, and they found the zeros, which is -1 and 5 over 3. So this solution is correct. Good job. Cool. All right, let's move on to question number 7. All right, so question number 7 reads, what is the remainder when 3x to the power of 4 plus 2x cubed minus x squared plus 2x minus 9 is divided by x plus 2? Okay, so we're going to use two different methods here. We're going to use long division and synthetic division. So I'm going to go through long division first. And the junior tutor also used a different method, and I'll also cover that method too, okay? All right, so let's use long division first, okay? So long division requires us, so I'm just going to, so long division requires us to have a big long bracket here. All right, and I'm going to have our divisor of x plus 2 on this other side, okay? So long division is similar to division, and you're going to treat each of the terms of a polynomial as a digit of your number in normal division, okay? And these are going to be also treated as digits. So all the terms in your divisor and in your dividend is going to be your digits, okay? So just like in normal division, you want to reduce this big number or this big polynomial within the bracket to the smallest size, to the smallest as possible, right? So instead of multiplying your digits by numbers, by other digits, to subtract from this large number, we're going to multiply our divisor by values of x, or variables of x, okay? So to get rid of 3x to the power of 4, right? So we have to multiply our divisor by x cubed, right? And not only x cubed, we want to also get rid of this 3. So we're going to multiply by 3x cubed, okay? If we multiply by 3x cubed, we get 3x to the power of 4, right? 3x cubed times x plus 2 is 3x to the power of 4 plus 6x cubed. And if we were to subtract this, we would get -4x cubed. Okay, now we're going to move down our next digit. All right, so how do we get rid of -4x cubed? We could multiply our divisor by 4x squared. Okay, so we multiply by 4x squared, we get -4x cubed minus 8x squared. And if we subtract all this together, this is equal to 0, and we get 7x squared. Move down our next digit, so it's plus 2x. How do we get rid of this? We multiply by 7x, and we get 7x squared plus 14x, and we get -12x minus 9. Okay. Okay. So now we want to get rid of this, so we just multiply it by a number. We multiply by -12, and we get plus 24. 24, or minus 24, sorry. If we subtract this, we get 15. So our remainder, which we were actually looking for in fact, is 15. Okay, so this is long division. We're also going to use synthetic division to also solve this too. All right, so synthetic division. Okay, so in the same way that we took a bracket, we're going to also make a bracket, but this time we're going to take a inverted division bracket. So we're going to flip it upside down and we're going to make it pretty large. This time we're not going to write down our polynomial. We're going to take the coefficients of our polynomial. So we're going to have 3, 2, -1, 2, and -9. Okay, and this corresponds to x to the power 4, x to the power 3, x squared, x constant. Okay, and instead of taking our divisor as it is, we're going to take the 0 from this divisor. So the 0 from this proposed factor is -2. Okay. All right, so what we're going to do now is we're going to move this. So we're going to do this kind of division. It's not really division. It's more of like finding the coefficients for your quotient. Okay, so we're going to move our first term down. So we're going to move it down here as 3. We're going to multiply our divisor or our 0 to the term and add it to the next term. Okay, so if we were to move our term down and times it by -2 is -6 and add it to 2, we would get 4. All right, and now we're going to do -2 times 4, -8. Add it to -1. Hold up, sorry. -6, -4. All right, so -4 would be 8. Add it to -1, which would be 7. -2 times 7, -14, plus 2, which is 12. Wait. Yeah, 12. -14, -12. And finally, we're going to take -2 times -12 and add it to -9. So that'll be 24 minus 9. That will equal to 15. Okay, so as I said, this corresponds to x to the power 4. The quotient is going to correspond to a degree lower than that. So it's going to be x cubed, x squared, x coefficient. And this last number is going to be our remainder. So this is our remainder here. This is coefficient, x, x squared, x cubed. Okay, so our remainder here is also going to be 15. Cool. Finally, the third method is what the junior tutor did. They've foregone all the division and they wanted to just test out what the remainder is. And this is a totally valid method. Okay, so this method, I don't really know what it's called, but we'll call it the substitution method, okay? So in the substitution method, they're going to take the 0 of the divisor and they're just going to sub it into the polynomial because they know there's going to be a remainder. So this whole talk about long division or synthetic division, it's to test whether or not your proposed factor is indeed a factor. And the test is that if you have a remainder of 0, then this is indeed a factor, and this is indeed a solution to when this polynomial is equated to 0. Okay, so in this case here, we know that there is a remainder. So what the junior tutor suggested is that we just plug in the 0 here, we plug it into the equation, and whatever value we get from that equation is going to be our remainder. Okay. So the 0 from our divisor is going to be x equals -2. So we're going to sub x equals -2 into our function here. Okay, so f of x is equal to 3x to the power 4 plus 2x cubed minus x squared plus 2x minus 9. Okay, so we're going to plug in f of -2 in here, and we're going to get 3 -2 to the power 4 plus 2 times -2 to the power 3 minus -2 to the power of 2 plus 2 to the power of times -2 minus 9. And we get 48 minus 16 minus 4 minus 4 minus 9, and that gives us 15. So that's a remainder. So we can see through all three of our methods, we got the same remainder, so this is obviously correct. And they wrote the remainder as the remainder over the divisor. So this solution is correct. Good job. All right, let's move on to question number 8. Sorry, just give me a minute. I'm just going to go to the washroom. Okay, sorry about that. I am back. So let's go on to question number 8. All right, question number 8 reads, what is the product of 2x minus 1 times x plus 4? Okay, so we're going to use the FOIL method to expand this. And the FOIL method, okay, so if we're given ax plus b times cx plus d, and we want to expand, then we use the FOIL method. So it's going to be like this. So we multiply the first terms, the outside terms, the inside terms, and the last terms, okay? And we have to think about this as like in distance in relation to each other, okay? So the first terms of each bracket is going to be ax times cx. The outside terms, if you think about this as there's insides and outsides, are going to be the two lateral terms, so ax times d. The inside terms, so now we're going to think about the medial terms here, so it's b times cx. And finally, we're going to think about the last terms, which is going to be the last term in each bracket, which is b times d. And we're going to add these all together. And what we get is acx squared plus adx plus bcx plus bd. Okay, so that's what we're going to do here with our factors, okay? Okay, so our two brackets are 2x minus 1 times x plus 4, okay? So if we were to expand this, we'll multiply the first terms together. So it will be 2x squared, right? We'll multiply the outside terms together, which is 2x times 4, which is 8x. The inside terms together, which is negative 1, negative x. And the last terms, which is going to be negative 4. And if we were to simplify this, then we get 2x squared plus 7x minus 4. Okay, so that's how you expand from given the two factors of a quadratic function. And we use the FOIL method to do so. So this solution is correct. All right. Question number 9. Alright, so question number 9 reads, solve the equation negative 9x plus 1 equals negative x plus 17. So they're asking us for the values of x, which will make the left-hand side equals the right-hand side. But the thing is that this can be problematic because there's values of x on both sides. So you guys can use trial and error, but we can manipulate the equation in such a way that we can solve for the values of x, which will make this equation equate to each other, okay? So by doing that, we're going to move all the x values to the left-hand side and all the constants to the right-hand side, and then isolate for x. So we're going to simplify the left-hand side until we only have x. Okay, so we have negative 9x plus 1 equals negative x plus 17. Okay, so the first thing is we want to move all the constants on one side and all the variables on the other. So we're going to first add x to both sides. So we add x to both sides, we get rid of this negative x on the right hand side. So we get negative 8x plus 1 equals 17. Okay, so we still see that there's a 1 here, so we're going to subtract both sides by 1. And what we get is negative 8x equals to 16. Finally, we need to get rid of this negative 8, so we're going to divide both sides by negative 8. Okay, so negative 8 and negative 8, and now we get x equals negative 2. Therefore, we manipulated this equation to find our value of x, which will make these two equations the same, which is x equals negative 2. Okay? The solution is correct. Good stuff. Alright, next question. Alright, so the next question reads, how do you write a third degree polynomial with zeros, negative 2 with multiplicity 2, and 4 with multiplicity of 1? Okay, so first of all, we need to define what a third degree polynomial is. And it's basically a polynomial with the max power of 3. So it'll be ax cubed plus bx squared plus cx plus d. Okay, where the maximum, I guess, degree or power is 3. So that's why you call a third degree polynomial. You can have different coefficients or different terms not in the polynomial itself, but this is the general form. Okay, so the question gave us the zeros and the multiplicity of those zeros, and they asked us to find a third degree polynomial. So in previous sessions I talked about the factors, right? So I talked about how, I guess, for a 2 degree polynomial the factors can be like ax plus b, so this is the factored form, right? Cx plus d. So the multiplicity relates to how many, the power of each of these factors. In this case, the multiplicity of these two factors are 1 and 1. Okay? Now, if we were to have a third degree polynomial, right? Let's say like this, and the factored form has a form like this. The multiplicity of this first term is actually 2, because the factored is being squared, right? So the multiplicity is 2, and the multiplicity for this is 1. Now, a good rule of thumb when you're considering multiplicities is that the addition of the multiplicities of all the factors should relate to what degree polynomial it is, okay? And that's why you never see any, that's why in this case, the only 2 different multiplicities is either you have this, where you have multiplicities of 1, or you have just this, which has a multiplicity of 2. Because it's a second degree polynomial, so the multiplicities can only equal to 2. So you have either 1 plus 1, or you have 2. In this case, you can have 2 and 1, you can have 1, 1, 1, you can have 1 and 2. It really doesn't matter, right? So going back to our original question here, so they gave us the zeros, right? Which is negative 2 with multiplicity of 2. Right, so we know that the first 0 of negative 2 will be squared, right? So if the 0 is equal to negative 2, the factor will then be x plus 2, right? Because when x is equal to negative 2, or the 0, it's equal to 0. So this is our first factor, x plus 2. All right, so if the 0 is equal to 4, the factor will then equal to x minus 4, right? Because when x equals to 4, this factor equals 0, and that is equal to our 0, right? So now we need to consider the multiplicities, right? So our first factor has a multiplicity of 2, and our second one has a multiplicity of 1. So therefore, our function f of x will be x plus 2 squared times x minus 4. Okay? So this is the factored form. They want the third degree polynomial, so we're going to give it to them. All right, so we're going to need to expand our first bracket, so we're going to use a FOIL method here. I'm not going to go too much into detail about it, but it's going to be x squared plus 4x plus 4 times x minus 4. And then we're going to expand, right? So we're going to have x squared times x minus 4 times x squared. So when you get to these trinomials times a binomial, you really can't use the FOIL method anymore. So think of it more like you're multiplying each of the terms in the first bracket by all the terms in the second bracket, right? So I multiply x squared by x and x squared to negative 4. Same thing with 4x. We're going to multiply 4x to x and 4x to negative 4. Finally, we're going to multiply 4 to x and 4 to negative 4. Alright, and if we were to calculate all this, it'll be negative 4x squared plus 4x squared plus negative 16 minus negative 16x plus 4x minus negative 16. Okay? So these obviously cancel out if we simplify, so we get x cubed minus 12x minus 16 as our third degree polynomial. Okay? So that's what multiplicity means, and from that, from the zeros and multiplicities, we're able to find the full form of the polynomial itself. Alright, and one final note, I'm just going to highlight again that the multiplicities of your factors, when they added together, should equal the degree polynomial. So if you had a 7th degree polynomial, you best bet that all your factors add to a multiplicity of 7. Okay? So this solution is correct. Alright, final question of the day. And it reads, how do you solve the inequality 3p minus 16 is less than 20? Okay, so in question number 9, I believe that we solved an equation. So this time we're solving an inequality, and it's asking us for the values of p, which will always make sure the left-hand side is less than the right-hand side. So in the same way how we solve question 9, we can isolate for p so that we can find the values of p, which will make this inequality true. So we're going to write our inequality again, and we're going to isolate for p, okay? So first of all, we're going to move the 16 to the other side by adding both sides by 16. Okay, so we get 3p less than 36. Now we're going to divide both sides by 3, and we get p is less than 12. So you guys can check this by subbing it into subbing p less than 12. So you can say, oh, let's make p equal to 11 and sub it in here and see what it is equal to, right? So you can do that to test it out, right? So that's the inequality. So whenever p is less than 12, p minus 16 is less than 20, okay? So that's how you solve for the inequality, and you guys can test that out. Let's say if p is equal to 11, then 3 times 11 minus 16 less than 20. So 33 minus 16 is 17, and 17 is less than 20, so that's correct. But what about if p is equal to 13, then it'll be 39 minus 16, and we would get 23. So when p is less than 12 is the correct answer for an inequality. Okay. Finally, the last thing I want to cover is that whenever you're dividing or multiplying your inequality by a negative number, you'll have to flip the sign, right? Because it has to do with making your right-hand side negative or positive, and by doing so, you have to change the inequality. You have to change your logic. Okay. So that's the last thing I'm going to cover on that. But other than that, the solution is correct. Cool. Alright, so that covers today's lesson. I covered 11 questions surrounding algebra and mathematics. So if you have any other issues with your homework or tests or assignments, please submit them to OneClass and we'll get to them as soon as possible. But other than that, I wish you guys a good afternoon. Goodbye, guys.